Today we are going to be starting Chapter 8. It will continue right in your notes booklet, and in this chapter it kind of tells you a little bit about what we're going to be doing on that page. So in your notes booklet it talks about in Chapter 8 we're going to be learning about adding and subtracting polynomials. And we're going to be multiplying and factoring. We're going to be looking at what binomials are, and we're going to be multiplying with special cases as well. And of course, factoring, lots of factoring. So in this first section, it starts with a lot of new vocabulary. So we'll spend a little bit of time going over that first. In this section, we're going to be focusing on adding and subtracting, but we also will be talking about what a degree is and how to name a polynomial correctly. In some cases, you can model a situation with an expression composed of what we call monomials. A monomial can be a number by itself, it can be a variable by itself, or it can be the product of a number and one or more variables with whole number exponents. So it gave you some examples here of what a monomial would be. And we can use monomials to put them together to form larger expressions, and these are called polynomials. A polynomial can be added or subtracted. Now, before we get to that, the degree of a monomial is basically just the sum of the exponents of its variables. The degree of a constant is always going to be 0, and 0 has no degree. So those are just some basics there. If we look at example 1 here, finding the degree of a monomial, these examples are already worked out, so you have some to kind of look back on. If it is a monomial, for example, we have 5x here, this first example. We look at the exponent with the variable. In this case, it would just be 1. So we would say this monomial has a degree of 1. If we look here at the next example, we have x and y, and they both have exponents. So we would add them together. So we would say this monomial has a degree of 5. Now, this particular step right here only works if it's a monomial. If it's a polynomial, it follows different rules for the degree. So just keep that in mind. 4 is considered a constant, so we would just say that has a degree of 0. Let's do a few here real quickly. So if you'd like to pause, you could pause it and go ahead and try to find the degree of each monomial here, and then unpause it and you'll get the answer, and that way you can see if you understand the concept. So pause right here if you would like, or not. I'm going to go ahead and go through it. So here we have a monomial, and we would say this is x to the first and y to the first. So we would say that it has a degree of 2. 1 plus 1 for our exponents. The next one here, we have 4 for an exponent and a 1 z to the first. So here we would say it has a degree of 5. And then C11 is a constant, so that has to have a degree of 0. So just a few other examples, and if you did them by yourself first, you can check those. Now we can add and subtract monomials by adding or subtracting their like terms. So let's look here in example 2. What is the sum or difference? Again, these are examples that are already worked out as references for you later. In this first problem, 3x squared plus 5x squared, they're like terms, so we can add the 3 and the 5 together. So we would write that as 8x squared. We don't need to combine the exponents. We're just adding, we're not multiplying. So this is where it sometimes gets a little confusing with the rules we did from the last chapter. So in the last chapter, we were generally multiplying or dividing. Now we're switching to adding and subtracting, and they have different rules. So keep that in mind. Here in the next example, we're just subtracting. There's a 1 here that we don't usually write, but we need to subtract the 1 there. So that would give us 3x to the third y. Again, we're just combining those like terms. We're not having to do anything with the exponents at this point. Here are a few other examples. Again, you could go ahead and try these on your own. You could pause it. If not, I'm going to go ahead and work those out as well. So in these two problems, again, we can combine these together because they have the same exponent to the same power, so they're considered like terms. When we add those, the first one, -6 plus 11, would give us 5. So that would give us 5x to the fourth power. The next one, we're finding the difference, so we subtract, and we get -5x squared y to the fourth. So just combining those like terms, not having to do anything with the exponents at this point. Now, the next part here is going to be how to label or name a polynomial correctly. So a polynomial is a monomial or a sum of those monomials. The following polynomial is the sum of all of these put together. So when you apply the plus or the minus in between the monomials, it now becomes a polynomial. Now the polynomial shown above is considered standard form. Standard form of a polynomial means that the degrees of its monomial terms decrease from left to right. So I think of it as you have the highest exponent first, and then it's written in decreasing order by exponent. The degree of a polynomial, like I said earlier, is going to be different than the degree of a monomial. When it's a polynomial, it's the same as the degree of the monomial with the greatest exponent. So that's all we have to look for here is the greatest exponent. In this example, 4 is the greatest exponent, so we would say the degree of this polynomial is 4. Different than monomials, so you've got to keep those two things separated, okay? Now we can name a polynomial based on its degree and based on the number of terms it has. So here is a great table as a reference for you. It's also from your book, and it gives you examples and how we would name it. For example, if the degree is 1 for the polynomial, we call that linear. And it has 2 terms, so it's also called a binomial. So we would name it a linear binomial. If we look at the bottom example here, 4 is the highest exponent, so that would be called to the 4th degree, and it has 3 terms, so we call it a trinomial, refer to it as a trinomial. Anything above a trinomial just becomes the generic name polynomial. And anything after cubic degree we just name it by its highest exponent. So 4th degree, 5th degree, 6th degree. So it becomes more generic. But there are some special names before that. So you want to kind of look at that and know what name goes along with what degree and what number of terms. Okay? Now the next part is to, of course, classify these polynomials. And again, there are some examples here already worked out for you, so you can kind of look at those as references. Here, it's nice if we put them in the correct order, or what we call standard form. So that means the highest exponent to the lowest, and then we can name it appropriately. The degree is 2 here in this case, so it's quadratic, and it has 2 terms, so it's a binomial. So we would refer to this as a quadratic binomial. The next one, again, it's nice to put it in order. And if there are any like terms, we should probably combine those together, simplify it. Then we can name it. So in this example, 3 is the degree, so that's cubic. And it also has 3 terms, so it's a trinomial. So we would call it a cubic trinomial. So here in the next few examples, again, you could pause it, go ahead and try number 3 here, and then we can move on from there. Okay, so I'm back, and the answer miraculously appeared. The name of this polynomial we would call a quadratic binomial. Notice I went ahead and put the problem in standard form first. The highest exponent is 2, so that was referred to quadratic. And then it has 3 terms, so that would be a trinomial. Sorry, totally caught that error. It happens. So quadratic trinomial, sorry about that. So there will be some problems on your assignment where I'd like you to practice a little bit naming the polynomial appropriately. The next part of this, I'm probably going to pause the video just to make sure I have enough time for recording. And so I'll make a part 2 and we'll pick it up right here where we left off. Okay, next video.